Functional groups are vital to molecular transformations, without which there would be no chemical reactions or even organic chemistry. In today's episode of CurlyArrows Learn Chemistry with Sibi, I will cover what are functional groups and how they are important in organic chemistry. The functional group is made of 1 to 4 atoms and they are responsible for bringing changes in an organic molecule. These changes occur when the functional group part of the molecule participates in chemical reactions, whereas the rest of the molecule remains largely inert. So the functional group is responsible for molecular reactivity and provides them with a typical character. What I mean by that is, if we can identify an apple from an orange by its typical characters of shape, color, and smell, similarly, a functional group allows the identification of a molecule, simplifies its classification, and further allows us to predict its nature. Now, this group of atoms called the functional group connects with the rest of the molecule using a single covalent bond. Its position in a molecule can be internal or terminal. Quite often, we see functional groups with heteroatoms like oxygen, nitrogen, sulfur, and halogen, or extra covalent bonds. So, identifying a functional group becomes relatively easy from the rest of the molecule by looking at the molecular structure. Some of the most important functional groups in organic chemistry are aldehydes and ketones, carboxylic acid derivatives, amines, alcohols, ethers, alkenes, alkyl halides, and more. A tutorial on how to identify and name a functional groups and examples of reaction wherein a functional group undergoes transformation I have covered in the Introductory Organic Chemistry course on CurlyArrows.com, a link to which I will place below this video. Classification of a functional group can be done in several ways. One way that I have covered in the article is when functional groups have only carbon and hydrogen atoms, or when the functional groups have halogen, nitrogen, oxygen, or any other atom. Other ways also exist, like when the functional groups are carboxylic acid derivatives. So, a molecule's functional group helps to identify and classify molecules. In addition, they also provide predictive outcomes in a chemical reaction. That is, molecules with the same functional groups behave identically under a similar reaction condition. For example, all molecules with functional group acid will react with a base to give salt, or all molecules with functional group alcohol will react with sodium metal and generate hydrogen gas. Therefore, a functional group allows one to isolate or identify an unknown compound based on its chemical properties. I will provide you with a hypothetical scenario. Suppose an oily, pleasant-smelling compound was isolated and its functional group is unknown. The pleasant aroma may lead to the belief that it could be an aromatic compound belonging to the category called arenes. However, in reaction with bromine, the unknown compound behaves quite differently from arenes. What is observed is that the orange-red color of bromine disappears, indicating a positive addition reaction. Only an alkene functional group always undergoes an addition reaction with the bromine molecule. In contrast, an arene will only undergo a substitution reaction and not an addition reaction with bromine. So, based on the characteristic reaction of an alkene with bromine, we could roughly guess the unknown compound to be an alkene. Let's say the oily aroma compound we isolated is menthene, a menthol derivative, though more tests are required to get the complete molecular structure. But for now, let us compare menthene with another alkene, ethylene. Ethylene is a plant hormone that causes the ripening of fruits, and it also reacts with bromine, leading to the disappearance of the orange-red color. We notice that both molecules have a common functional group, alkene, reacting positively with bromine. The one compound has a slightly more complex structure. Therefore, regardless of molecular complexity, the functional group behaves similarly in both the molecules. And this is what I mean when I say functional groups provide a predictive outcome. This holds true for every known functional group. The functional groups are very important in organic chemistry because they are responsible for molecular transformations by changing molecular structure. These structural changes occur when the functional group part of the molecule undergoes reactions like addition by connecting two molecules, rearrangement by rearranging atoms within a molecule, substitution by replacing a group of atoms with another, and elimination by removing a group of atoms. In addition, functional groups also affect a molecule qualitatively by affecting its physical properties of boiling point, melting point, polarity, and solubility. The chapter on physical properties in the Introductory Organic Chemistry course highlights this relationship. Therefore, chemistry of an organic molecule, regardless of its size and complexity, is determined by its functional group. For such bite-sized content reinforcing fundamental chemistry concepts, please subscribe to Curly Arrows Learn Chemistry with Sibi. You can also visit curlyarrows.com/premium-subscriber to see more of our premium tutorials.